Good day, students. I hope you're all doing well and safe and taking sufficient measures to prevent yourself from getting affected by this coronavirus situation. Thank you for joining this lecture. This is the 6th lecture of the course, and today we'll be focusing extensively on the things you have been looking forward to, the main things you have been looking forward to. That is, we'll be starting discussion on cryptocurrencies. Okay, so today's lecture will focus mostly on, well, it's sort of like a brief introduction to cryptocurrencies, so to speak. And as part of our discussion, we'll be focusing on a number of underlying technologies. So we'll start with distributed ledger technology, which is more or less the foundation on which cryptocurrencies exist. Then, having understood what distributed ledger technology, or DLT, is, we'll then discuss a bit about blockchain. And after having understood what these two technologies are, how they are interrelated or interdependent, let's say, then thereafter we'll focus on cryptocurrencies. We'll understand some of their nuances, understand how they operate, and as part of determining how they operate, we'll look at something called consensus mechanisms. So consensus mechanisms are key to the functioning of distributed or decentralized systems, and we'll understand how blockchain and cryptocurrencies really depend on consensus mechanisms. And to understand consensus mechanisms and develop an overview of why it's really necessary due to some of the issues that decentralized systems face, we'll look at this setting called the Byzantine generals problem, and look at some of the issues that the setting presents and see how consensus mechanisms can actually resolve some of those issues. Okay, and lastly, we'll dive into cryptocurrencies itself and focus extensively on Bitcoin, which is not only the first cryptocurrency to have emerged, but it's also it continues to be the largest cryptocurrency out there. So the last part of this lecture will focus extensively on Bitcoin, discuss some of its features, and compare its performance, its characteristics against other traditional forms of payments, other traditional forms of money, and things like that. Okay, so let's get started. So before we delve into understanding what distributed ledgers are and what blockchain is, we need some kind of a background. We need a foundation, a concept called the ledger, before understanding what distributed ledgers are and what blockchain really is. Okay, so the basis for any organization, the basis for any financial transaction, okay, is record keeping, right? Now, imagine you operate a bank account, right? You use that bank account to make savings. You use that bank account to receive salary. You use that bank account to manage your purchases and savings. Now, all these transactions that you make as part of your daily usage is recorded somewhere, right? Where is it recorded? It's recorded essentially in a ledger. So a ledger is nothing but a place, a bookkeeping place, where all your transactions are recorded, and that's essential not just for any individual. It's also essential for any organization. So an organization indulges in a number of different activities, and each of these activities have to be recorded somewhere. So the ledger is nothing but a collection of such records of financial transactions, for that matter. Okay, so ledgers have been used since ancient times. So they have existed since the time humankind learned to read and write, and they have been used for pretty much any kind of bookkeeping, any kind of recording, transaction recording. So ledgers have been used for recording contracts. Contracts meaning whenever two or more parties exchange goods or services as part of a transaction, it is recorded in a ledger. It is recorded so that there is proof that a financial transaction took place. It allows people to go back and verify the transaction if needed, right? And it allows people to verify the validity of a transaction. Secondly, ledgers have been used to record payments. So like I said, your bank account statement is in fact a snapshot of your transactions. So in other words, your bank account statement is part of the ledger that is maintained by the bank, right? Ledgers have also been used for managing sales and purchases. Okay, so whenever you purchase an asset like a house or an auto or something, there is always some entity. In this case, either your bank, if you purchase a house, or your auto salesman who's maintaining that ledger, which records the transactions that you make with that particular entity. And lastly, ledgers have also been used for transfer of assets and property, right? Whenever you transfer assets to somebody, so whenever your parents transfer property to you, or whenever you make a sale to somebody else, it's always recorded somewhere. So I guess by now you get the idea of what a ledger really is. It's nothing but a place where economic transactions are recorded. Okay, and the use of ledgers has been widespread since ancient times. So the earliest forms of ledgers were recorded on clay, because back then you had no paper or computers, and it was only possible to record transactions on clay tablets. After the use of paper became known to humankind, it started early in Egypt, where people learned how to use reeds and develop papyrus out of it that could be used for writing. Ledgers moved on from being recorded in clay tablets, which was very cumbersome, to a more paper-based format, and that has been the norm since those times, all the way up to the early 1950s. So until then, until 1950s, economic transactions or ledgers used to be recorded on paper. But obviously, recording on paper is human intensive. It requires a lot of effort. It's subject to damage, right? If you record something on paper, that preserving those paper-based ledgers is quite cumbersome. It's expensive and it's risky. And so, as and when computing started to become more widespread, like new applications started to be introduced, Microsoft came into the picture and introduced something called Excel, which all of us use. There were also a number of other software programs that emerged, like Tally. All these software programs and the emergence of computing allowed ledgers to be kept as in a more digital format. Okay, and so the need for recording ledgers or transactions on paper started to diminish significantly. But the thing is, all these software programs, whether that's Excel or Tally or anything, is managed by a centralized entity. If you're part of an organization, which is if you're part of an organization and you record a transaction on behalf of that organization in a software program provided by that entity, then it's that organization that is actually handling or controlling the operation of that software, right? So in most cases, ledgers are controlled by a central authority. But recent innovations have actually removed that need for central control. Recent innovations have allowed the usage of ledgers in a more decentralized or a distributed form, which is more secure. We'll see how decentralized systems or distributed ledgers are more secure than centralized ones. And these innovations and the introduction of distributed ledger systems have also enabled organizations to and individuals to store data in a more quicker fashion. Now, if you look at centralized ledger systems, especially in the context of banking, imagine, let's discuss this example and try and understand how ledgers have been managed in a more centralized fashion. So if you take this example, imagine a bank A, which obviously each bank within an economy serves a specific set of clients. So let's say we have bank A, and that serves a specific set of clients. Similarly, you have a second bank B in the economy, which also services another set of clients. Now, all these clients conduct a number of transactions as part of their interaction with the bank. They could go to the bank to save money. They could use the bank to make their payments, right? They could use a debit card to pay for coffee, but that transaction, the transaction of paying for coffee, is actually recorded by the bank in its internal ledger. So For all the transactions conducted by these clients, client A1 and A2, the bank is responsible for recording all the transactions conducted by these clients. Where does it store all these transactions? It stores in an internal ledger that it maintains for all its clients' operations. Similarly, Bank B also maintains an internal ledger on its own to record all the client transactions made by its respective clients. Now, in an earlier part, during lecture 3, we discussed that central banks, all these member banks, Bank A and Bank B, interact heavily with the central bank on a day-to-day basis, whether that's for access to interbank loans, or whether that's as part of regulation by the central bank, or whether that's due to the need for all these member banks to rely on a lender of last resort. So for all these purposes, the central bank on its part also maintains a ledger of its own to record all its transactions with its member banks. But essentially, if you look at each of these ledgers, you will notice that each of these ledgers is operated by a central authority. So Bank A controls the ledger of all its client transactions. Bank B controls its ledger for all its client transactions, and the same applies for the central bank, which controls the ledger of all member bank transactions. Right? So naturally, because there is a central authority controlling the transactions, it's that entity, it's that bank that is responsible for validating all transactions. So for all transactions conducted by client A1 and A2, Bank A is the sole entity responsible for validating all the transactions and preventing fraud. Right? What is the key requirement of such a system to function efficiently? First of all, the system can only function in an efficient manner if this ledger is trustworthy. Right? If clients A1 and A2 believe that all their transactions are being recorded in a fair and a safe manner by the bank. Otherwise, if there is no such trust in the system, then client A1 and A2 will not be willing to transact with the bank. So for this ledger to function in an efficient and a scalable manner, scalable meaning that this ledger can accommodate any number of clients, trust in that central authority is important. And the same applies for any entity, any bank within the system that is managing a centralized ledger. Now, against this, new innovations have spurred the development of distributed ledger systems. Okay, so conceptually, a distributed ledger system, or let's say a DLT-based system, is nothing but a database of transactions that resides across several nodes in a network. So obviously, here you had a centralized system where the ledger was being controlled by one central authority. But here, in a DLT-based system, the ledger is controlled by all nodes within the network. So this could be a group of member banks, or this could be a group of companies managing a specific set of operations amongst themselves. The context could be anything. But the main point here is most of the nodes that are part of this network are essentially computing devices. Okay. What are the requirements for this DLT system to work? Well, obviously, because the data is shared across all the nodes in the system, there needs to be a specific data structure in place that is able to capture, that is able to record transactions in a consistent manner. So having a proper data model that is agreeable and usable by all the nodes in the network is important. Secondly, this is a system that is waiting for new transactions to arrive. It operates on a live mode, it operates on a constant basis, and it has to be able to accommodate new transactions into the system, verify those transactions, and update them after verification to the ledger. So the second building block of a DLT-based system is a mechanism to verify and add new transactions and add them to the system and thereby update the ledger. And thirdly, because each node maintains a copy of the ledger, it's important for all nodes to agree on the current and the next state of the ledger. So what do I mean by that? There needs to be some kind of a consensus. There needs to be some kind of an agreement between all these nodes on the current state of the ledger and also on the updated state after these new transactions have been verified and added to the ledger. So these are the three building blocks of a DLT-based system. Why do we need consensus? Because There are two reasons why consensus mechanisms are important in a DLT-based system. The first thing is because the ledger is not only common, but each node has a copy of that same ledger. Consensus allows all the nodes to have the exact same ledger, not only in the current state, but also in the next state. So because of consensus, all the nodes are able to update the copy of the ledger. Secondly, because of consensus, it is also possible to prevent any actor from indulging in malicious activity. So imagine you have all these nodes. If one of these nodes or if a subset of these nodes is malicious, then consensus mechanisms also prevent these malicious nodes, these fraudulent nodes, from taking over the system and manipulating it to their advantage. We'll see how that works, how that works in practice by exploring the Byzantine-Generals problem. Okay, so this is a schematic, a general schematic of a decentralized network that works on a DLT-based methodology. So as I said, a distributed ledger system is a database, is a shared database of transactions where the ledger is synchronized across all the nodes. Obviously, each node maintains the latest copy of the ledger. There is no central authority controlling the nodes, meaning each node is an equal stakeholder in the system. Now, whenever there are new transactions coming into the system from any of these users, those new transactions are broadcast. They are relayed to every member in the network. And then each node is responsible for verifying the new transactions, the incoming transactions. And thereafter, they relay the validity of those transactions amongst each other. So this is the first step of achieving consensus within the system. Once that is achieved, then each node will update its respective copy of the ledger and once again relay across the network that it has updated its individual ledger. So that is the second stage of consensus where all the nodes are broadcasting the validity of those transactions and the updated status of the ledger so that eventually through consensus, the ledger is the updated ledger is common across all the nodes. Okay, so once consensus is achieved, the ledger can be updated and replicated across all the nodes in the network. That's how the system as a whole stays up to date and is then ready for accommodating more transactions as they arrive into the system. Okay. What are the benefits of having such a system? Well, first of all, there is trust, right? In a centralized authority, we saw that clients, the users of such a system that rely on that ledger for maintaining the transactions and for recording them, have to place extensive authority on the node, on the bank or the entity that is controlling that ledger. However, in a decentralized system, trust takes a backseat. So because the ledger is transparent, like anybody who's member of that network is able to access the ledger at any time and verify the transactions, trust sort of takes a lesser important role because trust is implicit in that kind of a decentralized network. Secondly, once a transaction is added to the ledger in a DLT-based system, there is no need for further validation. So you don't have to go back to that ledger and verify whether a transaction is valid or not. Okay, we'll see how that is possible by looking at blockchain. But for now, take my word that this is possible as far as DLT systems are concerned. Secondly, DLT systems also provide better security because, as I said, transactions that are added to the ledger or data information that is added to the ledger cannot be modified later. Secondly, the network can also withstand partial collapse in the system. So imagine some of these nodes go offline, they collapse because there's a power outage or they get destroyed or whatever. If there is a partial collapse of the system can still function because each node has a copy of the ledger. So in other words, this network as a whole can withstand a partial collapse because of this decentralized nature of the network. And third, even if some of the nodes are fraudulent and try to commit fraud on the network by manipulating the ledger or whatever, the DLT system is based on certain features that allow the network to identify these fraudulent actors as they try to commit a fraud, and it is possible to expel those fraudulent actors. and therefore prevent malicious activity from occurring. Okay, but despite having these benefits, current implementation of DLT-based systems are rather slow. So that's one major issue that is actually preventing the widespread business usage. So if you take Bitcoin, for instance, we'll see in the forthcoming slides that Bitcoin, although it is a very nice technology, it's nevertheless a very slow technology. It can only handle about 7 transactions per second, which is pretty slow for modern business applications like payments or usage as a normal currency. Secondly, operating decentralized networks is rather expensive because, again, to operate a decentralized system, you need to install multiple nodes, which, depending on your usage and depending on the number of users and the requirements of the system, can often be very expensive and hard to manage. And thirdly, adoption is also low because using DLT-based systems requires advanced computing skills. So current implementations have still not made it easy to use, and which is also preventing their widespread usage. Okay. Now, having understood what centralized systems are, centralized ledger systems are, and thereafter having looked at distributed ledger systems, distributed ledger technology-based systems, let's move on to understanding what blockchain is. So blockchain is nothing but one specific implementation of DLT-based systems. So in other words, blockchain is a subset of DLT-based systems. So DLT is like the foundation on which blockchains are based. And if you ask any layman as to what blockchain is, he or she would normally explain that blockchain is nothing but a protocol. It's a software program for sending money, which is rather simple because blockchain essentially has many different use cases. If you look at the more formal definition, more technical definition of blockchain, it can be described as a distributed peer-to-peer ledger, right, that keeps record of transactions through consensus, while providing a number of benefits like security, transparency, and anonymity. We'll see what each of these features is. Now, blockchain, as I said, is one specific implementation of DLT-based systems, or of DLT. And the difference from a regular DLT-based system is in the case of blockchain, as the name suggests, it's nothing but a collection of blocks. Okay. Now, the unique feature of blockchain is all the blocks are linked to each other in a chronological order, meaning the latest block gets added at the end of that blockchain. Okay. We'll see why that is required. But what is a block in this context? Well, a block is nothing but a group of transactions that are bundled together. So what happens is, in a normal blockchain-based system, a new set of transactions are simply bundled together. They are verified. And once that process concludes, the verified transactions are then added as a single block at the end of that blockchain. Okay. So you can see this with this example here. So here you have this big blockchain, right, comprising a number of blocks. And then imagine you have a new set of transactions that arrive into the system, which are then bundled together, verified, and put together in this block with an ID 292699. So in the end, once this preliminary process is concluded, this block is created and then added at the end of this blockchain. So all these blocks, along with the latest created block, become the new blockchain. Okay. Each new block has a particular timestamp and other digital information like digital cryptographic signatures and things like that cannot be modified. So that's one very important feature of the blockchain. A blockchain is very, very difficult to tamper with. Okay, it's not impossible, but at the same time, it's very, very difficult. Each new block, you can see here, is linked to the previous block. So there's a definite flow within the system, which cannot be changed. Okay, so this block 292699 refers to its previous block 292688, and that process continues all the way up to the first block. In most blockchain systems, this first block is called the genesis block because that first block gave birth to the entire blockchain. Okay, and another important feature of most blockchains is all the transactions that are part of this blockchain can be accessed at any time. So if I if I go to Bitcoin blockchain, you can see an example here. So this is, I just pulled it out today from a website called Blockchair.com. In fact, for most cryptocurrencies, you can access their blockchains because these are public. So this represents the latest snapshot of the Bitcoin blockchain. So the last mined block, the last block that was created as part of the Bitcoin blockchain has this ID 622553, and it has about 1752 transactions. So these transactions represent the latest transactions that arrived into the system. So these were bundled together, verified, and put into this block. Now, obviously, you can see the flow of the blockchain here. So this is the latest block to be created. Thereafter, you have this block, which has an ID 622552, and the flow continues as we go down. And you can, if you have enough resources and time, you can always go all the way up to the first block. And you can see the number of transactions included here varies with each block. That depends on the multiple parameters of the system. Okay. Now, blockchains in general can actually be categorized into two different types. So one is a public blockchain, meaning the data here is widely available, anybody can access it, and that is a common feature of most cryptocurrencies. Okay, because cryptocurrencies by their very design are meant to be used by the general public. So the blockchain underlying those cryptocurrencies can be accessed at any time, like you see in this, like you've seen in this figure here. The other type of blockchain is more private in nature, and these are called private or permission blockchains. So if you see, like you see in the second picture here, a permission blockchain is open only to certain people who have the requisite criteria to be a member of those blockchains. So access in private or permission blockchains is highly restricted, and in fact, in some blockchains, there are mechanisms in store to prevent users from conducting all actions. So members of permission blockchains, first of all, face certain restrictions in terms of access, and so meaning so only some people can gain access to those blockchains, and even those that manage to get access to those systems can only perform a specific set of actions. Okay, and sometimes those actions might require approval from some kind of a higher authority. So permission blockchains are more useful for companies to manage their internal operations. Okay, so these are used for very specific use cases, and most often these are used for internal record keeping and are not really useful for public usage. So in general, you have these two types of blockchains in existence. Now, you must have read blockchain before. You must have come across this term at least, and you must wonder that blockchain is nothing but a cryptocurrency, which is not true. In fact, blockchain is a more general term, which has many use cases. So a blockchain is not only used as a cryptocurrency. A blockchain, in fact, can be used for trading or settling any kind of financial transaction which needs record keeping. Okay, so that includes sale of any kind of financial instrument. It can be used for trading stocks or bonds or any other asset. And the advantage, at least, that is the advantage of using blockchain, at least in terms of what was described when blockchains came into existence, was that they would facilitate the trading and settling of financial instrument in a cheaper and quicker manner. That's actually not true in reality, because we see that most cryptocurrencies are rather slow compared to standard payment systems. But at least that was the promise made when cryptocurrencies were created using blockchain-based systems. Secondly, blockchain can also be used for other purposes, such as recording property transactions. So imagine in developing countries, especially, maintaining land records is quite difficult because there's no proper governance, there's no proper mechanism to record the sale and purchase of land or property, and in those situations, blockchain becomes very useful because because blockchain cannot be tampered with, right? Once a transaction goes into the blockchain, it cannot be changed or modified or removed. So based on that advantage, blockchains find a very good use case for recording property-based transactions, like land deals or rentals and things like that. And in fact, blockchains have been used to record property transactions in Honduras and elsewhere. Okay. Third use case, the third most vibrant use case of blockchain is in the area of contracts. So normally contracts are nothing but records of transactions between two or more transacting parties. Blockchains have been used to create something called smart contracts that are nothing but self-enforcing programs that operate on a set of pre-existing conditions. So I could create a smart contract at the time of lending somebody some money and say that the smart contract checks borrower performance. And let's say if the borrower violates one of the conditions embedded in that smart contract, then I can enable that smart contract to execute some conditions that will be triggered on the basis of that violation, and therefore allow my money to be repaid back. So in other words, I can create a smart contract at the time of providing a loan that would enable that smart contract to get triggered if the borrower violates the terms and conditions. So what do I need to implement a smart contract? I need to define the conditions under which the borrower might violate my contract, and enable the smart contract to track the borrower on a constant basis and check how he or she is performing. And once that is violated and detected by the smart contract will be able to draw into the account of the borrower and enable my money to be repaid back without any kind of involvement from my side. So smart contracts are autonomous systems that operate on their own. We'll see more of smart contracts in the next lecture and see how these resulted in the creation of initial coin offerings. Okay. Lastly, blockchains, because of the fact that blockchains enable the use of enable the storage of information that is immutable, meaning that cannot be changed or tampered with. Because of that feature, blockchains also find tremendous usage for storing identity-based information. So blockchains have been used to create identity management systems that enable the storage of data on individuals or assets. So for instance, individual data could be fingerprints or iris information, and blockchains enable the storage of such sensitive information. Now obviously these cannot be stored on a public blockchain. So in most use cases involving identity management, blockchains are mostly permissioned systems. Okay. Now lastly, based on the discussion so far, so until now we have looked at distributed ledger technology, then we have looked at blockchain, and now we'll take a deeper look at cryptocurrencies and the rest of this lecture. But before going there, I want you to understand that many publications, many news articles, many blog posts tend to discuss all these terms interchangeably. So in many cases, sometimes somebody will say distributed ledger technology, and somewhere down the article, they might use this term blockchain. But I want you to understand that although all these three terms are interrelated, they are not necessarily the same. Okay, they follow a certain conceptual hierarchy. Distributed ledger technology was the first to emerge that led to the creation of these distributed storage systems, right? Blockchain is one specific implementation of DLT that enables the storage of data in a chronological order in the form of blocks. Cryptocurrencies emerged from these blockchain-based systems. Okay, so there's a certain hierarchy where each successive system is an implementation of its underlying technology. Okay, as you can see in these, using these two arrows here. So I want you to understand and be careful when you discuss these in your assignments or in the future as to what you're really talking about. So be very specific as to what kind of particular technology you're referring to when you discuss something crypto. All right. So in the next part, we'll look at why we need consensus. What is the need for having a consensus mechanism in decentralized systems? All right. Thank you so much.